All right, day 18. We need to find the shortest path in a grid from 0, 0 to 70, 70. We have a bunch of walls on the grid. So this is the exact same problem as day 16. But I thought for this I'll use a library that I saw other people on Reddit were using called Pathfinding. So I've added CGMath, Pathfinding and regex to the project already. So to get the shortest path, we'll use Dijkstra algorithm. So we just need to provide the start position and the goal end position and the neighbors for each path. So start by just reading all of the numbers. So that will just be digit plus unwrap, and then get all of the captures from the data. Map each capture, call it C, and it's only one, and we need to parse and unwrap that, so we parse the string to an isize. So then we need to chunk it, so we read 2 at a time. And we can map that into AVEC2. So data chunks 2 at a time, map each chunk to AVEC2, new, and collect that. So these are all of our walls. Then we'll create the start position. 0, 0. We have an end position at 70, 70. And then we also have the size of the grid. That is 71, because this is inclusive. So then we need to find the shortest path. So we'll use this one. We can copy the documentation and write a similar. So we'll say result will be Dijkstra, and the start will be start. Successors, we need to take in a point and return the successors. We can just return empty for now. And in the end, we want to check if we have reached the goal. So that would be p equal to end. And in the end, we can print this. So this will return the path and the cost. So we'll just say result expect failed path finding .1. And then we can implement this getting the neighbors. So I've defined the 4 directions. So we can just do directions, do into iterator, And then map each direction into the position plus the direction. And then we need to in the end map the new position and also say that, so we'll have that as v for vector v, and the cost is 1 because we have to return the cost. And can just say let n neighbors be this and then return it. Good to be able to inspect it. It's unknown at this point. So is it still unknown? No. So now we should get a result, I think. 140. This is of course without the walls. So we need to filter. First of all, we want to filter everything that is outside the grid. So we need x to be bigger or equal to 0. Same for y. And then they both need to be less than size. And then we also need to filter the walls. And so we don't want to take all of the bits. We just want to take the first 1024 bytes. So we can say filter is equal to, and then do a slice of the data. So we want to start at the beginning and we want to take up until including 1024. No, not including. Yes, including, I think. Oh, we'll see what if we get the correct result. So we only want where filter contains, does not contain this. So we'll run this and we get 260, which is the correct result. Then for part 2, we want to find how many bits to block the exit. So we can just brute force this. It's not a problem, but because it's not that many. But it's faster to do a binary search. So we can create a low, and we know that this will be at least 1024 because that was the answer to part 1. And high will be the length of data. And then we want the best. And we'll say that is none for now. then we can search while low is less or equal to high. We'll do the whole pathfinding, except we do not want to panic the program when we fail. That is actually what we are looking for when it fails. So we want to find the midpoint. So mid will be equal to low plus high minus low divided by 2. And then filter will be, instead of 1024, we will do to mid. And then after the result, if result is none, that means we have cut off the path. So this could be the best. So the byte should be this one. But and that is the new best one. And we need to say that it's sum. And then high will be mid minus 1. Otherwise, low will be mid plus 1. In the end, we should print, and it should be printed like that, right? So then we get 2448, which is the correct solution.